Hi, it's 9:30, and I'm Tom DeFanti, and I am the lead of this session, and I'm going to start off. Mike Farley will be next, and then Dhusdee and, no, then Dung Vu, and then Dhusdee and Willie will present. So this is about CENIC AIR and the California State Universities, and what we've learned in the past little over 2 years that we've been doing this. I want you to take away the following, please, is that CENIC AIR is a university community-owned, college community and university owned and operated cloud that provides a relatively barrier-free entry into AI usage and also HPC usage from chats to student lab experiences to advanced research. It's also quite clonable and by design. CENIC AIR's computers are optimized for AI, which makes offering large language model access very efficient. This access is free for our authenticated users. We started out doing an AI focus with this because the universities have supercomputer centers which do lots of HPC, and I frankly, as a startup thing 10 years ago, did not want to compete with the supercomputer centers because they'd squish me. So I decided to do something they weren't doing at that point, which was doing AI with game computers, believe it or not. So we made machines out of game computers, and that went for quite a while until it became difficult to do that. The reason why, so this is all part of the National Research Platform. And in California, we call it CENIC AIR because in starting to reach out to the CSUs, we discovered that people didn't have enough networking experience to set up science DMZs and do the kinds of things that many of the UCs could. So CENIC started offering network planning services, and after a couple of iterations, working with San Diego State and Humboldt, I guess, came up with a little package to build a science DMZ at very low cost in your facilities at the CSUs and community colleges districts we've been working with. So CENIC is called CENIC AIR because of CENIC adding the networking engineering and also outreach activities with Leanne's been running this conference with a lot of people, and it's an important piece of what they do is they've been promoting CENIC AIR for the past year, her group, communications group. So that's why CENIC AIR is the California part of the National Research Platform. The website is nrp.ai. So memorize that. Okay, so first, this is going back years ago, driving the car that my son has now worn out. John Graham and I delivered machines to Stanford, Santa Cruz, Santa Barbara, Merced, Irvine, and Riverside. And just stacked up my Highlander and drove around and plugged them in. These are all 2080 Ti-based machines, and so they're all old, and then one of these days they'll be taken out of service. In the meantime, people have added a lot more to them. But then 2 years ago, we started with the CSUs, Chico, Scott's over there, and Cal Poly Humboldt actually got their own machines from NVIDIA donations. Sac State, Monterey Bay, San Diego State got their own machines. You'll hear all about Tide from Mike. And San Bernardino, Fullerton, and San Diego Community College District. In the Fullerton case, they drove to me and picked up a computer, and then they multiplied it by 20 times or something. So very successful. And more recently, the Los Angeles Community College District, the Cal Poly Pomona, CSU Fresno, and CSU Northridge started hosting nodes. And CSU Bakersfield will soon add nodes. So this is great. Here's what the map looks like, a little bit more details in terms of who's got what GPUs and CPUs. You'll see that in CENIC AIR, which again is part of the NRP, has about I don't know, 2/3 or 3/4 of the GPUs and approximately half of the CPUs and 2/3 of the storage of the whole National Research Platform. Now, why is that? That's because we started out with a thing called the Pacific Research Platform, and we had about a 5-year head start on everybody else. This is very nice and tightly organized and being added to. This map had about maybe 1/3 as many entries as recently as 2 years ago. So it's been really doing very well. So I went and made a list of people who I call CENIC AIR champions, and I tried to give these little gold and blue pins out to people, depending on whether they're, actually the gold ones went to people who are hosting equipment. And so these are people whose emails I was able to pull out of my, gazillion messages. So I could identify people we could pin here at the conference. If I didn't pin you and you're on this list, catch me in a little bit. But it does take a lot of people. And the interesting thing is that most of these people are user, faculty-facing, student-facing support people. And some of them are sysadmin people, but the whole idea of CENIC AIR has been stated a few times in this conference, is to help share the administrative responsibility so that campuses can really push their energy towards faculty and students. So why CENIC AIR? So I quote Lewis Fox, who's, of course, been supporting this fabulously. And so the idea is to be able to develop and refine topical AI curricula. Now, CENIC AI resource, right? The fact that people also use it for HPC quite a bit is something that I learned from my colleagues here. And you can tell because if somebody configures machines with either 64-bit GPUs or a lot of CPUs and memory, then they're doing HPC. And if they're doing, so far, up until recently, if you're doing AI, you used a lot more GPUs and could do 32-bit ones. So develop and refine topical AI curricula constructively contribute to the transformations promised by these new technologies. In other words, use them, don't be abused by them, and collaborate extensively with colleagues nationwide over the NRP. This happens automatically because you don't typically know or care where you're computing. It's somewhere. So you go onto CENIC AIR and you might be computing in Nebraska. But we add CENIC's network planning, engineering, operations, and outreach to these efforts, which has been really critical. So for CENIC AIR in education, why? So we're at the beginning of a revolution. Again, this is Lewis's words I copied. AI makes personalized tutoring possible before, during, and after the classroom session. This is a big deal, actually, to get it so that there's a one-on-one thing between teachers and students we can't afford. We can't afford one-on-one between AI tutors and students. And so AI redefines what's possible to teach in a classroom. But now, Lewis says, barely 8% of California colleges can afford to offer AI in the classroom. And AI is an experiential thing. It's not so much as theoretical science, it's experiential. And you have to do it. It's no good watching it. You want to do it. So CENIC AIR enables the other 92% to also offer AI in the classroom by reducing the total cost of ownership of this infrastructure. And it also allows and encourages research engagement with local industry and even high school students who come in for college advanced placement courses. That's been kind of a good thing. And it gets the high school students, they're able to use the authentication services and interact with the faculty that they may very well be with the next year or two. And that's important because so many of the, say, high schools go to the local community college or to the local CSUs. So the benefits is that we provide storage. You can, we don't try not to make it permanent storage. We don't want to be the graveyard for your files, but working storage. And then these things also fit into bigger projects like Open Science Data Federation, Globus, and the National Data Platform, which has been covered on Monday. There's lots of other storage options. The National Data Platform sits on top of the NRP. Currently, it uses mainly NRP resources, CENIC AIR resources. The whole idea there is to be able to catalog data sets and make it easy for people to get at them. They're also now expanding into AWS. And then the code that you do, if you're actually doing containerized code, then you can run that on commercial clouds. And I tell people is debug on CENIC AIR, and then if you're lucky enough to have commercial cloud credits, burn them after the code's working. Don't burn them when you're trying to debug. And so that, that works pretty well. The University of California, San Diego runs a thing called Cloud Bank, which is a way to get credits for these various cloud services in a very advantageous way. If you don't know about Cloud Bank and you want to use any of the big clouds, you should Google it. We're currently using 34 of our GPUs, which is not much, to offer 9 different large language models. We try to pull down the latest ones and offer them to people. They've been very, very popular. And we see a lot of pickup from people who, as we say, have just learned to spell AI, but they know that they want to do, they want to do large language models or use AI. And this, of course, is the first way of doing, learning how to do prompts. Okay, so I am going to switch over now to Mike. And let me get the proper window up. Where'd it go? No, that's not it. Oh, yes, PowerPoint, thank you. Oh, back to PowerPoint window. That's what happened. And that one, right?
Good morning. My name is Mike Farley, Chief Technology Officer at San Diego State University. Take you on a little bit of a journey. We actually go back a little bit on this. We had our first Science DMZ that was created by some SDSU faculty and researchers, Dr. Jose Castillo and Dr. Chris Paolini. I think John used to work with them. So they brought a Science DMZ to campus back in 2012. I think it was one of the original CC stars in networking in that area, so we have to give credit to them. And they've had a couple machines on the National Research Platform since then. I think they're still up and running, actually. Getting a little old. So we love a good name at San Diego State University, like many of you. So we've kind of given a name to the resources that we brought to CENIC AIR. Makes it a little easier for us to talk about on our campus. I have to give credit to Jerry Sheehan for both of these names, so I'm not going to take credit for it, but go back a little ways to late 2022. We created a faculty-led committee. Everybody loves committees, but this one had some good output on it. So we had faculty from every college that we asked to go back to their colleagues and ask them, what do you need? And we didn't limit it to teaching and learning or research, but we did want to know what they needed from a cyber infrastructure perspective. So compute, storage, networking, we left it incredibly vague so we could see what they came back with. There were some, the results showed a couple of things. One, GPUs. They all wanted GPUs. We didn't have very many on campus. And from a software perspective, a lot of them had identified Jupyter. Jupyter Notebooks, Jupyter Lab, JupyterHub, which was good. Given what we knew about the National Research Platform, now CENIC AIR in California, we created a proposal and got funding for about $650,000, which pretty substantial. So with that, we were able to, which probably doesn't go as far today, but we were able to purchase 15 nodes, bring 32 NVIDIA A100s to the National Research Platform under what we called FERN. And the focus for us was on teaching and learning primarily. You'll hear in a second where that's had very slow growth, so I'll talk about how that hardware doesn't just sit unused. And then TIDE, Technology Infrastructure for Data Exploration, is an NSF award that we received in January of 2024, so a little over 2 years ago. And we'll talk about that a little bit more in a second, but that's focused more on research. So we've got these two things. We have Vern and TIDE at San Diego State University that are part of CENIC AIR. So on the Vern, what we call STAR Instructional Cluster, it's part of CENIC AIR. That's available, obviously, at no cost to our faculty and researchers, and we're focusing on teaching and learning. So with that, joining this hardware to the National Research Platform, CENIC AIR, really gives us a lot of potential to focus on the enablement of that platform, less about the systems administration. We would not have done this had we had to administer the servers. So our team is focused on primarily building containers, granting access to JupyterHubs, supporting the faculty and the students in their course usage. We did that by leveraging students too. So we created a group within our group called a Software Factory. So we've had a few students that have gone through that since 23. With that, they're building software containers, they're learning source control, they're learning how to use GitHub, how to do CI/CD to build those containers and automate it, and do support. So that's one way we're able to support Classroom is by leveraging students. And we've had two of those students have gone on to get jobs in the field. One of them works at GoFundMe. So they actually told us the skills they learned here were more applicable than what they learned in the classroom, which was nice to hear. Some of the stuff they never mentioned in their courses, and these are CS and MIS students. JupyterHub obviously is the front end. You hear that a lot. It's the easy button. We deploy those. You'll hear that from everyone else here as well. We couldn't do it without JupyterHub, I think, at this point. So that's a great project. From a growth perspective, we started very small, which was good. We ran into some issues as we tried to figure out how to operationalize this. But as of today, we host, it's a pretty small number, but over 20 courses. I should have updated this for this semester, but a little over 20 courses, 500 to 600 students per semester, which is pretty good. These are resources these faculty did not have before. The tough kind of a lesson learned here is getting the word out. So we do go to new faculty orientations, we do department meetings, we do everything you could think of to try to get the word out there. And it's always just not enough, right? There's a lot of room for growth here as we continue to support this. So on the TIDE project, with that, the proposal, we set out a couple goals. One was to create a computational core within the CSU, not the computational core, because we've all are starting to deploy hardware, which is great. But we knew there were many campuses that had the same need for GPUs that we had at San Diego State University and did not have support staff necessarily to support access to those GPUs. So again, TIDE funded about 26, or NSF funded about 26 nodes that we added to the National Research Platform, operated by them again, so we're focused on the facilitation and use of that. The project itself, we give back about 20 to 28% the past 2 years to the broader community. So that other set of resources we make available to CSU, faculty, researchers, and students. So at the end of the award, that might change, but right now we're kind of leveraging that requirement of 20% that was laid out in the solicitation. We created a TIDE support team, which several folks here, Dung is a part of that. So this, and I should point out, this is a joint award with SDSU, Cal Poly Humboldt, CSU Stanislaus, CSU San Bernardino, where Dung is from, and San Diego Supercomputer Center. We did create a support team to operate that. So we've got staff members, students, has funded some graduate students at all of the 4 CSU campuses that help support this. We intake tickets from any faculty or researcher to any CSU can submit a ticket, and we'll take that. We may send them to another campus that has resources to support CENIC AIR, or our kind of core team will help them understand the needs, build containers, facilitate access, or partner with NRP and send them somewhere else. So really it's kind of an air traffic controller, just making sure they get the support that they need. Kind of a repeat slide here, but we took what we learned from Vern, applied it as far as software containers, JupyterHub goes. We've had pretty good results. We've had over 1,300 faculty, researchers, and students at some of the institutions. We're not using this at SDSU. We use Vern for teaching and learning, but I think Dung, I don't know if you're talking about it today, but they're using this in the classroom as well, some of these resources. So we've had a user, at least one person from all 22 campuses log in, some of them many more users. So just a high level on some of the community. Our TIDE support team, we've brought in those participating grant campuses, but we've extended that to anyone else. So we've done things like walk through, made recordings of how to deploy JupyterHubs so that we can share those with the next set of people that need to do that. We've offered workshops, hands-on tutorials. We've partnered with the NRP staff as well to do some of these workshops. The CSU does a good job of collaboration, I believe. We've had some existing, I see some CSU people in here, so you know this, but we've had have existing alliance groups, our Network Technology Alliance, our CAST. We recently created a Research Computing Technology Alliance group, has members, I think, from just about every campus. It's very broad, focused on research computing, which kind of lives in different areas at different institutions, but that's a space we can share information. Some of it is CENIC AIR related, some of it might be cloud, AWS, it just depends. We've had Cloud Bank present there, for example, to get the word out on that. And then the theme of this conference is the right connection, and I think that's the people connection. So 2 years ago, I was introduced to Rose, I don't believe is here at the moment, from San Diego Community College, there she is, San Diego Community College District. So we left here and worked together and kind of pointed them on the direction to be able to offer a server on CENIC AIR. So some of that was helping with, hey, you need to be a part of InCommon and do the federation, which they did. We helped them deploy a JupyterHub instance, which I think is still running, right, Rose? Yeah. So this is a great place to learn from each other. And then most recently, we were invited to present or provide a workshop to the Central Valley Accessible Research Computational Hub. I don't believe she's here. So we did a TIDE/NRP workshop to CSUs in the Central Valley that are part of that, as well as UC Merced. So that was very successful. Had about, I think, 25 faculty researchers attend that. So with that, I'm going to spare you the animation here, but I did want to point this out. CENIC AIR has actually been very interesting. In fact, it's driven our network upgrades at San Diego State University. We started with a very small network supporting our science DMZ, which really just kind of looked like this. A slow backup connection to Riverside, not capable of supporting CENIC AIR, dark fiber over to SDSC. A year and a half ago, we decided we need to get this upgraded. We're taking this seriously. We have 41 nodes on CENIC AIR, as well as some additional servers on our science DMZ. So we upgraded our backup connection to 100 gig, supporting science DMZ, which is great. So we can actually fail over and sustain an outage. We upgraded our campus science DMZ to 800 gigabit and our campus enterprise network to 400. Again, all driven because we needed some capacity to support stuff on CENIC AIR. We extended CENIC to Calexico, so working with CENIC and the Chancellor's Office brought a connection out there that can support science DMZ. So as we think about research projects out there, Internet of Things, sensors, we heard about the vineyard stuff, there's all kinds of cool potential out there. And then our new Brawley building came online, $80 million STEM building, kind of in the heart of the agriculture, but Lithium Valley. So we have a new degree, 2 new degrees, chemistry and electrical engineering. And similar, we brought CENIC out there and can support science DMZ and CENIC AIR use cases. So looking forward to what the future brings, especially working out east there with our faculty and researchers at those 2 campuses. That's it for me.
Hello, everyone. My name is Dung. I came from Cal State San Bernardino. I would like to share our experiences with bringing HPC to college in our locality. So thanks to a very handy tool, especially a few years back, when we know that NRP have the have a tool to deploy JupyterHubs. So the uses of SPC in our campus have the great leap. So with that success, we thought about spreading the luck to the community around our campus. So that's the motivation to bring the SPC and AI education to a college student in a fast, efficient, and accessible manner. So we follow a model in construction, the BOT. So build, operate, and transfer. So first, with the BOT, we are able to build dedicated JupyterHub for two community colleges in our campus, in our community, which is the San Bernardino Valley College, Crafton Hill Community College, and Chapter Community College. Each system, they have like 20,000 students, equal to our campus population. We also help Loma Linda University doing the research, and now like the few professors there are using the NRP resources for their research, and also one professor using NRP to teach their class using the IA100 GPU. So with that, the BOT concept, so we deploy dedicated college JupyterHubs using the NRP cluster. So with that one, we deploy popular images like RStudio, Julia, Python, data science. So, and then with that popular images, we assist faculty in preparing curriculums. We help to customize and develop the new software stack per request. So with that system, we try our best to ensure resource availability, reliability, and stability. Those are very important factors to make sure that the faculty and student are satisfied with the system we provided. And we provide full technical support to ensure faculty successfully complete their research and students complete their assignment. So that is our efforts to assist the JupyterHub we deploy for the colleges. So once those systems has been carried out, have been deployed, we step by step, we are using presentation and even invite the college staff to attend RP regular training to get them catch up with the tool that we know before. And also, we assist college staff in deploying JupyterHubs and developing and customize the software stack. So after that, after the college staff are confident to the management of the system, we completely hand it over responsibility to college. So that is our step. So this is the map that I planned. So the top is NRP with the cluster, so with the community, with the AI. So beside on the right is our CSUs, and then we use the BOT model to deploy JupyterHub for colleges. At the same time, we let them connected, interact with NRP. So for them, they will completely taking care of the system like we do. So this is one example of the JupyterHub we deploy for San Bernardino College District, which include Valley College and Captain Hill. So this is the same like we use for our campus. So the lesson learned, we use both bottom up or top down. Bottom up is that we are approaching instructor to introduce about what available, what they can do. And also, we contact at the top level. We contact, for example, San Bernardino school districts. We contact the chancellor office. We contact the one taking care of the academic training. And then we work with the director of ITS who help us to deploy the authentication, because the student in the community college, they just use single sign-on, use the CI log on to access array, so they no need to create any user account anymore. So very convenient. And we ensure the satisfactory assistance with the timely solution and quick problem solving. That is very, that's our effort. We try to make sure that once the professor use the system for class, it must be reliable, and any problem of the student when they access the system must be solved. So with that one, so when the NRP have the chance to expand infrastructure, so we will include more population of the student. That's a very important factor. So that's when we're trying to do right now. And then actually the NRP and SDSC provided tremendous tour, tremendous opportunity that we can bring the chance to use resource computing for their research, for the study, especially with the AI education. That is more very important. I really appreciate again NRP and SDSC again for their efforts. Thank you.
Well, we really appreciate you too. And one of the points is that as we've been developing this over the past decade, researchers are fairly okay, especially if they're getting a free resource and it goes down for the weekend, and which on Friday afternoon something dies and everybody wants to take the weekend off. We can't get away with that anymore. We really have to have it up for students and teachers. You can't just give up and say, yeah, we'll pick it up again on Monday when the project's due on Monday. So we've really had to improve things, and it's mostly because of the instructional community. Okay, now I'm going to this other one here, which is, I think, Command Shift F. Does that get us to the beginning? And then to the beginning? There we go. I'm almost a Microsoft person now. Good.
Okay. Hi, good morning, everyone. So for those who don't know me, I'm from Cal State Fullerton. And today we're going to focus on more of the collaboration. So if you don't know, how CNI started was a project called Infrastructure Terminal Research Project back, I think, in '97. Willie knows because he's around in '97. And then it became the CNI, which is what is actually supports all of our campuses today. So we are, CSU is unique in that, and I love being part of CSU in that we are a campus of collaboration. We're really a community that really supports each other, regardless of what campus we come from. And this is really important in relation to how we got started with NRP. 2 years ago, I came here not knowing, not having heard of what NRP or Nautilus is, and I came to some of the talks. I saw Dr. Larry Smart's presentation, Tom's presentation, and also I listened to the panel discussion for SCSC, for the San Diego Community College, and I was like, wait a minute, what are all these resources that we don't have on our campus? And that's when I met Dung, and he actually, in the lobby over there, took out his laptop and said, here's what it is, and he actually set us up to be able to access the San Bernardino JupyterHub. And like that night, I just went in, got started, did things, and I was like, wait a minute, we have to bring this to Cal State Fullerton. And that's how our journey started just 2 years ago. So we went down to San Diego, picked up a box from Tom, and then with the help of CENIC technical resources, we got our Science DMZ. We had already some Science DMZ, but we needed to update our network slightly, so we did that. And there's, without the help and support of San Diego, we reached out to AJ and some other folks, and San Bernardino, and even the Chancellor's office helped us out, provided support. Kendra was like, what do you guys need to get this moving forward? Without any of these, we would not be where we are today. So it truly is a coordination of coalition for us to, fast track to where we are.
I want us to talk a little bit about that last slide real quick. So during the 2024, when we're first logging into NRP, there were only probably about a handful of the campus that I can see during this logon. But as you can see today, all 23 campuses has CI logon to NRP service.
So just to give a little bit more context, why we're so passionate about this is that in 2022 was when our campus was designated as an R2 campus, so we're relatively young in that area. And then also our students did not have the resources to learn, for example, they're learning CUDA and some of the other coding things, and it was all on paper. They didn't have anything hands-on to work with, so everything was just theoretical, paper, question and answer type of learning. And bringing this resources to our campus allows our students to have that hands-on experience. So it's a really huge step forward for us and also for our students. So in that, we were able to implement, get our namespaces up and running, work with our faculty, computer science faculty, to bring this to the classroom. So we had 1 or 2 computer science faculty that we started off with to really champion this, to bring this to the classroom. And also we worked with some research faculty to apply this to their research data analysis. So what Willie and I literally did was, hey, give us your data. What data are you looking at? So we put that into JupyterHub, and then we did some data analysis and said, hey, look, this is what this can do for you. And so from then on, we just went to every department meetings, classrooms, talked to every faculty, did some sample lessons, whatever we could to really show this to our campus, and build namespaces, build images, whatever we could do to really, spread this across.
Right. A couple of things we did together, and then I think this is definitely what I call the CSU way, is when we start looking at other CC Star and the CEF grants, we start kind of pulling some of the campuses together, and thanks to Kendra and Tom and all the other folks who says, what do you need? What can we help you? How can we write proposals together? I think this is one of the things that, even though the particular grant, I think they pull out the grants already, but I think those are part of the activities that we've done to try to enhance what the CSU campuses are good for. The other pieces that we've done, being within CSUs, there's so many different activities we've done together. Like Dhusdee kind of mentioned initially with just the ITRP CNI. We also have a lot of other different groups. We meet on a monthly basis. We share each other what knowledge that we have, both probably between Dhusdee and I, we were probably in most of our CSU-wide activities. So we spread NRP and Nautilus almost on a monthly basis. What we've learned, connecting the network together, thanks to Carl for getting this template set up at the very back. And then so we shared that networking knowledge, working with CENIC, and then apply to the other campuses where there are interests. And that's what kind of Tom alluded, where quite a few campuses already has the network or the high-speed network that's already being built out throughout the CSUs. And I think we're continuing to build that across CSUs just because the network components, how CENIC is able to provide to us with that ability, we're able to utilizing our existing equipments and provide that Science DMZ to the other campus. I have to put a plug on our next presentation, which is coming up in another next hour or so. And these are all the other things we've done within the campuses. And we'll talk a little bit more about how we reach out to the faculty, the students, setting up some of those activities that we've done outside of the CSUs. We're looking at inside of the Fullerton, what can we do? And then we'll share our knowledge and our know-how. And we definitely like to have a lot more collaboration, conversation with each other and with the L2. So this is what we learned. Definitely all the folks in here that talk about the reusable, shareable modules on Jupyter Notebook. We started with people, right? This is something that we cannot done with just the technology. You can implement the technology, but without the people, technology just be by itself. We do see that, of course, being 23 campuses, all the way from Humboldt to San Diego, there are several different knowledge base. Some people are really good at it. San Diego, San Bernardino, they started up very early. And then when we see that there's a need, we pull our groups together. We have a lot more discussions. But I think we still have a long way to go. I think we reach out to probably, I call it less than 10% of our faculty student population. So we do have a lot more that we need to talk among ourselves and then share what we can do together. So the takeaway for us is scaling AI and Nautilus HPC across CSU campuses is not simply just deploying infrastructure. It's about building that collaborations, and so we can carry it forward. And with all the collaborations efforts and the groups that we already have together, I think we can align our efforts and our sustained engagement. We can then move our technology forward. I think many people already mentioned it many times during the presentation, and is if you want to go fast, you go along, right? But if you want to go further, you go together. And thank you.
Okay, I'm just going to fade to black. Okay, so we have plenty of time for questions, about 15 minutes, and we did this intentionally to try to get some interaction from folks here and what they want to know, what they've learned. And you want to take a mic? Here. Okay, thank you. One of the things that we've been considering as we branch out more into the few remaining CSUs, and there's a lot of community college districts out there for us to hit, is how do we make it more of a package? And can we, to make the rollout of the rollout of a Science DMZ to a campus or a district office, should that also include, besides the networking connection, should it include a basic Nautilus node? So people, the first one is hard to do because you got to tweak all the MTUs right and all these other kinds of things. And as a matter of fact, it's easier with the newer networks like San Diego Community College District. After CENIC was done, I literally went there with this unit in my car, plugged it in, and there were jobs running on it 10 minutes later. There's other places we've worked with where they struggled for 6 months to get the older your network is, the worse it is to do these things because you've got to find all the places it doesn't do it right. So, but having a kind of a standardized, simple unit that people can plug in as their first piece, and then on top of that, once you get the first one working, the rest of them are easy, and everybody goes, oh, well, that's easy, and it works. So we're discussing that with Scenic Engineering right now. Larry?
Wonderful talks by real pioneers in California, all of you. So I have two questions. The first one is more of a technical question for each of you, which is if you have an idea, how much of the time used on your campus on Scenic Air is on your local installed by Tom and John and the rest of them, and how much is reaching out, for instance, with Vern? It's, how much of the coursework takes place on the Vern cluster versus the halo of basically NRP around it, and the same with the rest of you. First question. Second question is, but all of your campuses have been extraordinarily successful in spreading across your campus the actual usage, because I can go and look at those statistics and see that. That's rare across the campuses that have a few users, because I just looked at all 800 of them or so. So to me, the real bottleneck at this point is how we go from the campuses that have a number of users, maybe in different departments or something, and then those become seeds across the campus. It just doesn't happen automatically, or else we would have seen it by now. And you all have been very successful, and you mentioned a number of the techniques you use. But I would love to see in the rest of this calendar year some of those applied to a lot of the other campuses that do have users to start, but there's just a few, and it's not spreading on the campus. Those two questions.
Those aren't questions. Those are statements. But yeah, like I say, it's in jeopardy. I'm sorry, you failed to pose your response as a question.
Was your first question more about our like FT supporting it as far as how much? No.
Just how much of the cluster time, the GPU time, for instance, off your campus within the NRP is used as compared to the amount of time on the cluster that is on your campus, like in Vern. So the courses, how much do they end up?
Bursting. At our campus, so we operate a bunch of different JupyterHubs. One is for teaching and learning. It doesn't burst at all. So Vern, for example, is 15 nodes. It's 32 A100s. Based on how many courses we have that semester, some of those A100s are divided with MIG mode into 7 cards each. So we try to find the sweet spot to support the number of courses that we have. Everything else that's part of Vern, we make available to the general NRP to use. But our JupyterHub only looks at that hardware that we've purchased.
Of course, at the end of the quarter needs to, if at the end of the quarter or semester and everybody's trying to get their stuff done, can the students then go off of?
In our case, no. No, we restrict the launching of those containers as pods as jobs within that hardware set. We did that originally, and we could change that. It was easier to support. We knew where they were launching, and if there was a problem, we could quickly at least figure out what the problem was. And we did have some issues with stability or scheduled maintenance that we didn't know about at the time. A lot of that's changed. There's a lot more communication, announcements, change management around maintaining NRP, and that's important because research, we get it out. Oh, it's a research system, no problem. Teaching and learning, those students are up at 3 a.m. trying to submit something on a Sunday for something that's due Monday. That's hard for us to justify. Oh, sorry, we didn't know about that. So in our case, no, we do not burst that JupyterHub for teaching and learning to the broader community. We could. On Tide, we do do that. We target that tied hardware first, but we do make available other resources, specific GPUs, for example, if they're needed.
With regarding to our campus in terms of resource, our campus, JupyterHub mainly, we use two resources. First is the Tide, and also together we use NRP. So in case we always have the Tide for our campus, and then when we don't have enough resources, we tap with the NRP, and then we constantly monitor the resources, so we know we know we check which one are like some pod running for a while, and then you check the activity. So it is quiet. We let the user to be shut it down. And then we quite control the usage of resource. But in the long term, we need more resources, because if we expand more user to community college, that could be a challenge.
So I would say from watching you guys operate over the years that you guys are net suppliers, and he's a net user of resources. And I know this because early on, one of his biggest users is a researcher who needs 64-bit GPUs, and we only had one, which was at UC Santa Barbara. And so I know that they were using that very heavily. But you've got a fairly small number of GPUs. I think it's 19 on your campus, and you've got hundreds, and you've got 100, and it's, or more. And so it is, and really, everybody really thanks you guys for having all that stuff.
Which we're fine with. We have the space, we have the cooling, we have the power, we have the network, we have the staff to operate the data center. So we're more than happy to contribute hosting of systems, even if they're not specific to SDSU. And I think that's probably true for a lot of us that have potentially extra
And you're also
space.
fulfilling the requirements of this great grant that you got a few years ago. So you're right on track. Over to you guys.
So at Fullerton, we set up several different namespaces for different purposes. So for the research namespace, that we give flexibility for faculty to select their, for example, GPU types, number of GPUs, et cetera. And that is pulling from the first available resources. For a classroom, we found that because of the limited time that students are in the classroom, and also with classes that are 40 to 60, to have all the students try to reserve pods at one time, we needed a way to make it quick. So for that one, we prioritize our local resource on our campus, our local cluster. And we did several different tests before start semester and throughout the semester, just to make sure that that is still a good user experience for our students. So it takes within just a minute. Students nowadays, their attention span is very short. So we had to make the user experience positive for them. And then to answer your question about other disciplines, we were very intentional early on to make sure that the resources is not just limited to our College of Natural Science, Mathematics, or Engineering, Computer Science. We wanted to show our campus that this is something that can be used in all disciplines, and also to encourage, going back to our collaboration, to encourage collaboration across disciplines as well. So Willie can probably talk more, or if you come to our session later on, we can go into more details about some of the things we do. But we've partnered faculty from across disciplines to work together. For example, if one faculty has a lot of data, we can maybe have them work with our data science, and then also with our computer science students to write Python scripts. So we were taking that idea of collaboration and doing that cross-discipline.
So just like what Vern is doing initially, they were looking at how the classes or conducted on the instruction. So we did talk to our faculty, our deans initially, when we actually pull some of the fundings together. because we feel that, yes, we can definitely leverage the NRP group to help us be able to spin up those pods initially, but I think we do need to have something that we can sustain internal within our campus. So that's, and based on the specifications that Tom initially and Grant and John provided, we spec our own specifications on the node. So one of the things that we did is we packed 16 GPUs in a 2U boxes instead of 8. And so we were able to gain 6 nodes, 16 GPUs, 96 GPUs for our own classroom use. And later on, we found out that, hey, we need our own storage. So we learned that we need to have minimum of 3 Ceph nodes. So we built 3 Ceph nodes to build our own Ceph cluster. And I think that helps out, first alleviating some of the contentions that the NRP Ceph nodes was having that issues during the time. So we're able to kind of sustain that operations within the campus. So once the hardware is done, tainted some of the nodes because we do need it for our own use, but most of the time it's released to the NRP. And I do think that find out that some of the L4s are being used heavily now, which is really impressive and interesting.
And we do have the capability of fencing off, they call it tainting nodes for people's specific use. Sometimes researchers say, I really have to do a run on something and not be interrupted, and I want to have the machine that I bought reserved, and so we do that. But it doesn't usually last very long until they're done. They're just trying to do something that's very measured. Jeff.
Yeah, so Jeff Weekly, UC Santa Cruz. I, like Larry, do not so much have a question, but a comment. I just wanted to say, I wanted to shout out to you in this effort, especially SDSU. This relationship doesn't just flow from the big institutions down to the little institutions. This is a two-way conversation. And for many years, in fact, as soon as I got to UC Santa Cruz, I said, where's your Jupyter hub? Why aren't you doing Jupyter notebooks? I went over to the instructional design people, and they made a list of everything they do, and Jupyter wasn't on there. And I said, that can't be. This was 2019. So I was a little ahead of the curve there, but today, we still didn't have a solution. But because of CENIC AIR and because of the work that they did at SDSU that I learned about at 6NRP, I could come back to my campus and say, listen, we don't have to struggle with finding a software as a service provider or owning our own hardware. We can just nestle this into CENIC AIR, just like SDSU has done. And they met with us, they taught us, we learned how to do it, we did a prototype, and now we have that service on campus. And it's because of the leadership of the people on this panel that happened. So thank you.
So remember, the SDSU, the CSUs, some of them are pretty big. I mean, there's 2 of you guys are over 40,000 students, you and you're right. So there's they're not little places.
40,000 students with 2 research computing staff for the whole campus. Right? It's some of us have a lot of folks, some of us don't, and I think it's the sharing. It's the only way we can do it, and that's why we're up here, right? Yeah. Thanks, Jeff.
And I really do love the CSU community. It really, Kendra introduced me to people a couple of years ago, and it's been great. There's a lot of sharing. A short question or statement.
Yeah, I might be opening a can of worm. My question is, do you think that we should start curating some of the courses that you're teaching at your institutions? Is there a need for that sort of thing? And I'd leave it at that.
Yes.
Yes, too.
Well, it's what, and Frank, we've had this conversation for a couple of years now, not you and I, but just in general. Like, I'm good at putting things in a data center. I'm good at connecting to the network. I'm good at deploying JupyterHub. It's getting that faculty engagement and getting the digital assets, the curriculum piece that we struggle at, and we struggle with getting the connection with the faculty. We know they're teaching stuff, but I sent an email to 3 this week about what we had talked about, no response yet. Right? So yes, but we got to find the right way to do that.
Yeah,
And maybe Fullerton's cracked that code.
So definitely, yes. I think, that we have the technical implementation side, but really the huge part of it is working with the faculty. We also have a close relationship with our Office of Sponsored Research Project. So one of the things is, for example, we have machine learning class, natural language processing class that was prior to this just on paper, but we've transitioned it to the Jupyter environment. We started an AI class, a lower division 8 applied AI class, which at the start of this was only able to teach one session, but now we've grown to 4 sessions because of the resources. I'm working with a faculty in one of our colleges who's developing a whole new course in humanities that is going to use, I'm working with them to develop some data science Jupyter notebooks to incorporate as part of this new class that they want to write up and propose to our campus. So definitely the partnership is so important, and yes, we are keeping track of all of the classes, the courses and the curriculum that we are helping to develop as well, because that is really what's going to spread across the campus.
So then let me make a very practical question. In the past, we sometimes set aside time at the NRP meeting to have brainstorming sessions, right? Should we have a lunch together at the 7 NRP meeting to brainstorm about how?
Yeah.
And what and how this would all work out if one were to do this?
So just during our time, I was talking to Gerald and Mike that we are at Fullerton, we're building a program called Shareable Canvas Module. And I think that probably can hopefully introduce more faculty from different disciplines to interact and be able to share how they use Jupyter Notebook.
So should I put this on the agenda and figure out a time in the room?
Definitely, yes.
Okay.
Yeah, but that's one of the other things that we're going to talk about in our next session.
Okay.
So
Thank
we
you.
have, we're over time, except for the fact that the
Time is
break
our
is
next
still
session, Willie?
3 minutes away. We still have 3 minutes until the break starts, even though our session's over. So one more question, anybody? Oh, there's one in the back, all the way in the back. Get the runner there.
Thank you. Excellent presentations. Thank you very much. My question is more about capacity and where we are in the sort of growth cycle here. So the first question is, when do you get to the point of saturation where you're really pervasively available and people are using it, and faculty are using it, students are using it in a broad-based kind of way? How far away are we from that? And when we get there, what kind of capacity issues will we be facing in terms of availability of resources?
Okay, so there's a couple of answers to that. We're probably running about 60% capacity right now, I think, and that's comfortable. We have a couple of users that we intentionally allow that are huge users, and they're also not contributing to us. Partially, their contribution is that they run this huge background job all the time, and one of them does. And we know that it's helped us tune the stability of the system over the years. If we kick them off, we get about another 20% of usage, So we do have some flexibility in terms of, and we've got one other like that that's we could ask to go either start contributing resources or go to the cloud or something. But the trick with this whole thing is that it's very easy for us to add capacity by pouring money into it. We don't need to build new data centers. We don't need to build new networks. We don't need to build new staff. Just add computing to it. And the GPUs have been getting exponentially more expensive, but also very much more powerful. So that's a good thing. And there's more people coming online. The other thing that's happening is that as we move more towards the large language models and more towards using AI, which means inferencing as opposed to training, that's a lot easier to support. The stress on the systems is way lower you can take a lot of people in with these large language models compared to the computer scientists and data scientists that are training them. So we've got a lot of capacity. And
I'd answer it more broadly. We push, this is just one tool out there, right, regional and nationally. So there's other things that we recommend and help people get access to, whether it's NAIR or Access or something else through like DOE. Sometimes it's kind of NRP is not a good fit for certain workloads. So this isn't the only thing to look at. So we do push people to other resources as well.
Well, we teach them here. So, all right. Thank you very, very much.